All right, so hello everybody. We're going to learn about materials. Since there's not enough people for today, we are going to just do it by myself. So, first of all, we're going to learn about materials, substances, and particles. And as you can see, look around this whatever this place is and find all the different materials. Which one is a solid and which one are liquids and gases? All right, so this is a solid. This is a basketball. This is also a solid. Oh yeah, you should. These are all solids technically, and also the chair, the table. But this is a gas. This is a liquid. This is also a liquid. And whatever this is inside here is, yes, also a liquid. How do we determine it? A solid, a liquid fills the shape of its container. So as you can see, this is the shape of a container. You don't really, if it was a solid, it would be a little bit different. Similar to here, you can see the water fills the shape of the container. The coffee doesn't look free. The gas, however, doesn't look free. It just fills like its container. The gas, it flies to space. It literally just goes to. It doesn't fly to space. But it is very lightweight. That is how you determine the state. So we're gonna see. On some different types of materials. For example, these are some materials that things could be made out of. So, for example, salt is a solid substance. However, pure water is liquid, while oxygen is a gas. So, but most materials is actually made out of a lot of different substances. For example, paper is made of trees and other fibers. Um, uh, um, Plastic is a polymer and it's made out of a lot of other chemicals. However, something like however, however, something like pure oxygen is a substance, and glass is material. Why is glass a material? It is added with sand, limestone, and soda ash. And then they become clear liquid glass. Yes, not solid, liquid. And this glass can turn into a lot of different shapes. You see the beer bottles that your parents may drink. It's in your lights. It's in your windows. It's in your everything. Glass, it's in your screens. It's in everything. Yeah. So, we know that all matter is made out of particles, and a particle is very small, like really, really small. You can't even see it, or a little bit of something. Some of them are really big for us to see, such as dust or sand. But a lot of them are too small for us to actually comprehend. So matter is something that has weight or no, has mass and takes up space. All right, it has mass and volume. That is another word to say something takes up space. A material is made of a lot of things. A substance, on the other hand, is made of the only itself. Glass is a material because glass is made out of sand, soda ash, and limestone. Sand and pure water are similar because they are substances, and they're different because one is solid and the other is liquid. Yeah. So, um, so because most particles of matter are really small, scientists use a model. A model here is like whatever. A model is a thing that represents something. For example, represents a scientific thing. For example, you can see a model of an atom. People use models to describe an atom. Okay, so that displays the difference between the liquids, gas, and solids. For example, we have a yes, we do. As you can see, this is a model for a solid. It is tightly packed. In a liquid, it looks very freely packed. It is packed, but not as much as a solid, and it is not in order. They are different. They are in a regular pattern as solid, but they're really small. And therefore they're in a fixed position. All right. So, um, so, um, so it's simple. This is in a solid, you put yourself as close as possible, but in a liquid, you make yourself free. You see the difference between your arms. So in a solid, it's more of intertwining arms, something like that. Well, in a liquid, it is just holding arms, which I don't know anybody likes that at all. Yeah. So, um, this is an experiment that we couldn't do. How do solids and liquids behave? So there are a lot of things that solids and liquids do. So say about these sentences are true or false. I will stop for 30 seconds so that you guys could answer. All right. So all substances are made out of particles. True. Materials are not made of particles. False. Everything is made of particles. Particles in solids cannot move. No, they can move, but they're just vibrating. So technically, no. Particles in liquids can slide past one another. Yes, there are always space between particles. Of course, you can, unless you make it into a black hole, there will be a little bit of space in solids as well. So, a property is a part of what it behaves, and we can measure, see, or feel the properties of the substance or material. And as you can see, the solids and liquids have a wide range of properties. So, can you squeeze a desk or chair or a pencil? Well, you can't do that. That's because a solid is so tightly packed that it needs a lot of force to change. Therefore, there is not a lot of space for the object to change. However, a liquid, if you put a liquid in anything, you can make water change its shape, which is correct. Well, it technically does. Liquids change their shape because it takes the shape of its container. So yeah, Zara, I can make the water change its shape. No, you can't, Sophia. Anyways, so Sophia's correct in this case because water can technically change its shape because if you pour it into a glass compared to if you pour it in a table, for example, water will be for example like this, and the water, for example, would be like this. So yeah. There's a lot of difference between water changing it. Water does change its shape. You can try this at home, or I could try this here. Like for example, if I put water here, you can see I don't know if you can see it, but it does land on the hand. But once you put it on something else, for example, this bottle, the water will take the shape of the bottle. So yeah. Can solids behave like liquids? Of course, yes. So some solids are really similar to liquids. Sand, flour, salt, and sugar are some examples. If you touch and if we pour these solids, they fill their container. What is this? These are powders. These are a lot of tiny grains that have a lot of space. But these particles are made of a lot of these powder grains are made of a lot of small particles. That is why they are still considered solids. Not only that, but if you're in the high class, you're going to learn about non-Newtonian fluids, which are fluids that act like solids. So yes, solids can behave like liquids and liquids can behave like solids. That is completely true. So we're gonna learn about melting and solidifying. And have you ever tried to eat ice cream and then it melts? Yeah, that is called melting. Melting is when when a liquid becomes a solid becomes a liquid. Sorry, and not only that, yeah, a solid can always become a liquid, as this example shows. However, the opposite could happen, and that is known as freezing. You can freeze water to make it into ice. Not only that, but they have a lot of different properties that we have just discussed earlier. So yeah, they are really changeable. They can change itself into a solid or a liquid. So most materials can change and substances can change from one form to another when they're heated or cooled. This is known as change of state. And solids, liquids, and gases are the different states of matter. As you can see, Siberia's ice cream solid as a solid, but then it started melting because it changed to a liquid. So it is known as melting. As you can see, this is a way to show solid causes a liquid. This heating causes melting. You'll learn in another grade that there's also more complex things about solids and liquids that also because of this. Solidifying is the opposite of melting, also known as freezing in some cases. Yeah, exactly. She is true. They must be very cold until they become solids. And they lose, and when liquid substances lose heat, they become a solid. And here's how we could show that it becomes a solid. All right. Have an ice cube in a saucer. Yeah. So, as you can see, you can put an ice cube on a saucer, and is the ice cube liquid or is it solid? How do you know that this ice liquid is liquid or solid? Well, you know it's a liquid because it melted from the ice. And also, if you touch the ice, does the ice feel hot or cold? Or a saucer is like a saucer is like basically pan, I think. Yeah. So, hold the ice cube in your hand over the saucer. Does it feel hot or cold? Of course, it's gonna feel a little bit hot because it gets hot. And what do you think will happen to the ice? It will probably melt. And if you say it was melt, correctly, it's correct. And this is melting. Yes, exactly. This is about melting. So, what made the ice change shape? Change state. Sorry, I didn't read it. It is because of its. Yes, it's because of its heat that is transferred from the saucer pan to your ice cube. And did the ice change into another substance? No, it does not. It only changes state. Note that when you melt or solidify things, it is still the same thing. In this case, it's H2O plus heat, and then you get H2O. It's the same thing. The only thing different is that you added heat. So actually, there's no chemical reaction happening when your ice is getting frozen. What? All right. So there is a process. What is this process when the opposite is happening? It is known as freezing or solidifying. So we are back to our model, and as you can see, they are always moving. They're always moving. Even though they are really solids are not even look like they're not moving, they are moving. And exactly, it is yes, it is very tightly packed, so that's why they couldn't move a lot. And as you can see, these particles gain energy when we heat the substance. Therefore, they will start to move around way more. Therefore, it breaks these bonds. And when it gets some time, when it gets hot enough for these particles to get more excited to the point that their bonds break, that is why you know that you just completed a phase change. Not only that, but when liquids cools, the opposite happens actually. Actually, these bonds start to form because these particles are starting to slow down to the point where they connect to each other and become ice or solid in this case. And yes, see, there is a model that becomes liquid to solid with less energy, so they become less excited. All right, so what is this? So as you can see, as you can see, oh, a sausage, a plate. Wait, what? Oh, that was a pan. All right. Anyways, so you can see there's some butter, a chopped piece of chocolate, and some ice. Which one will melt first? It's obviously the ice cube. Why? The melt point of ice water is 0 degrees Celsius, or the freezing point. So, because this is room temperature around 25 degrees Celsius, you will have to wait for some time until the bonds get excited. Chocolate, on the other hand, has a higher melting point, and you have to wait for some more time for it to actually melt, or you have to keep it for some time until it melts. And then butter has a really high. Butter becomes more of a solid in this case. You have to make it stay into a liquid or solid for a really, really long time. So yeah. As you can see, you know gold. It's unmeltable, right? No, it isn't. This is melted gold. It actually the reason why the gold bars are shaped like this and have so good letters is because people make a mold for this gold and they pour the gold down and wait for it to cool, and they take the bar and sell it. This is how this, and therefore this is actually melt. Gold is essentially even if you think gold is unmeltable, it is actually meltable. You can melt gold, but you have to heat it so high that you need a really hot torch. And if you touch it, well, say goodbye to your hand. And finally, chemical reactions. What happens to chocolate when you heat it? It melts. It melts. And what does the chocolate change in any other way? Well, it becomes a liquid. And then, can you change the chocolate back to the way you heated it? Well, of course you will. You can't change it back because if you freeze it, it becomes chocolate. If you mix nuts with the chocolate, how does with the heated chocolate, does the chocolate change to a new substance? Of course, it technically does, but it's still chocolate. How can you take nuts out of this chocolate? Well, eat the nuts or cut into so small pieces to the point that you can take the nuts out. Nut chocolate, just legendary. Anyways, making new substances. All right, so change of states is a physical process that changes the form. However, the substance never changes. But when some substances are mixed together, they become another substance or material, and this is a chemical reaction, and these react together. So if you mix cement powder and sand, you get water and limestone, you get concrete. Wow. And you cannot turn concrete back to water or sand or cement powder or in limestone. Most chemical reactions will be like this. Burning wood is also a chemical reaction. When we heat the wood, it reacts with the air. The gray substance called ash is created. And it also creates more ash or gases. This is why whenever you weigh the wood before and after burning, the ashes that you get left is way lighter. The gases go away. And now you can see there's a lot of old tin cans, but they're so brown. What is happening here? Is this some kind of dark magic? No, it's rust. Rust is when you keep it near oxygen and water. for some time, mostly water, until it becomes this brownish substance, especially on metals. Usually it's iron oxide, but there's also other metals that could be rusted. So yeah, that's why you can see a really bright rust. Fun fact: a Statue of Liberty is actually green because of its rust. If you were to remove the rust in the Statue of Liberty, it would become brownish, and it's made of copper. Same with the scent. If you keep it for long enough, it becomes green. So, um, so water wool. All right, we can't do that. It becomes rust, by the way. So you see, these old cars become rust because it reacts with the air until the point that it becomes brownish, and therefore it becomes rust. So, um, so, so, have you ever bought a frozen fruits? Well, oh well, you can see how you can see which foods freeze a lot, and do solid foods freeze faster than liquids. And also, you can also make your own question. And there's a lot of things that you could do with this experiment. So yeah, um, so is this so it is made of particles. This is a solid. Yes, I'll do extra solid. It cannot change shape easily. Oh no, this is not solid. This is both. This is both, right? I'm sorry. B for both. All right. Yes, solids cannot change easily, and liquids take the shape of its container. Solids have very small spaces between particles, and both have their particles always moving. And when it's heated, it melts, which is a solid. Water is an example of liquids, but it can also be both. It can also be both. So this drawing represents a solid or a liquid. As you can see, these are really free packed. They're tight. They're packed, but not tightly. So we would think that it's a liquid. For example, you can see that it's packed, but not tightly packed, and it's disordered. It's disordered. It is very disordered. It is a solid. Flour is a solid, but it behaves like liquid. So okay, we will not do that. So, so how would they do a fair test to take how much time it melts? Yes, you can always put the same amount of butter and margarine together. No, not in the pan. Yeah, if you put it in. Instead, test 3 is correct. All right. And not only that, but what? Each pan on an identical stove. Yes, here. Yeah. So there, you put equal amounts of butter and margarine in 2 different pans, 2 different but identical pans, and you have to heat each pan on an identical stove starting at the same time. You cannot do this. You cannot do 4. You cannot do 6. You cannot do all the others. That is how you make a fair test. You must make both of the conditions the same. I thought that was a spider. So Sophia put a nail into a saucer of water, a plate. After 3 days, she noticed that the nail is now reddish brown. Why is that? It's because of rust. Yes, it is rust. Not only that, you need water, metal, and oxygen. You need just water and metal sometimes. Yeah. And also a saucer. So it can be a problem because it weakens these metals. Rust weakens a lot of these metals. And And this is known as a chemical change / chemical reaction. So, that is all we're going to learn for today, and I hope you have a good day. Yeah, thank you.